morning students. Today we will discuss one of the GATE question which is given in GATE 2014 related to conflict serializability. Now before solving this question, let me discuss what is conflict serializable schedules. We have discussed yesterday what is conflict equivalence schedules. What we have said about two schedules are conflict equivalent. Let's take that I have a schedule S1 and I have a schedule S2. When I can say that schedule S1 is conflict equivalent to schedule S2 is if the conflict operations, the number of conflict operations, we have two conditions to say that schedule S1 is conflict equivalent to schedule S2. We have said that there are two conditions. What is the first condition? The number of conflict operations in schedule S1 and schedule S2 should be same. And the second one, the order of the conflict operations also should be same. So that is about the conflict equivalence. So we will use the conflict equivalence concept to solve the conflict serializability. What is conflict serializability is when I can say that a non-serial schedule S1, when I can say that a non-serial schedule S1 to be a conflict serializable is if it is conflict equivalent to any of its serial schedule. I hope you are understanding. When we can say that a non-serial schedule is conflict serializable is if it is conflict equivalent to any of its serial schedule, then we can say that it is conflict serializable. So they have given 4 non-serial schedules. Among these 4 non-serial schedules, they are asking which one is a conflict serializable. Now you can ask me, sir, if I have 3 transactions, transaction 1, transaction 2, transaction 3. Now we need to find how many serial schedules are there. Among these serial schedules, which one is conflict equivalent to the given non-serial schedule, we have to find. So if I have, let's take an example. If I have 3 transactions, then we will have 3 factorial number of serial schedules are possible. One of the example is transaction 1, then transaction 2, transaction 3. And another one example is transaction 1, transaction 3, then transaction 2. Like that we will have 8 serial schedules are possible. So we have to do it is that for these 8 serial schedules we have to find the conflict operations, and for the given question also we have to find the conflict operations, and then we have to match whether it is matching with any one of this or not. If it is matching with any one of this one, then we will say that the given schedule is conflict serializable, otherwise it is not a conflict serializable. Then you can understand how much pain to solve one option itself. So this process is not feasible to solve in the GATE, so we will use the precedence graph concept to solve this question. So let me explain how we will solve this question using the precedence graph concept. Okay. So first we will solve the option A, whether it is conflict serializable or not. If lot of people will confuse to draw the precedence graph using the direct like this, so let me draw the table for each option and I will solve the precedence graph. So first let me explain what is this R1 is. It is a read operation on a data item X by performing by the transaction 1. Similarly, W2 of X means it is a write operation performed on a data item X by the transaction 2. Okay. So if you see that we have R1, meaning is that we have a transaction 1. If we see that we have R2, the meaning is that we have a transaction 2. And here we have R3 of X. So meaning is that we have a transaction 3. So how many transactions are there in this equation? 3 transactions are there. Transaction 1, transaction 2, transaction 3 are there. So first thing is that you need to identify how many transactions are there. So in this question we have 3 transactions, transaction 1, transaction 2, transaction 3 are there. So first how we will convert this sequence into a table is that first you need to identify what is the first operation is performed. R1 of X. So in the transaction 1 you write read of X. Is it clear? Because it was written R1 of X, in the transaction 1 you write
R of X, meaning is that read on a data item X. Then the next operation performed is R2 of X, meaning is that in transaction 2 you write R of X. Then W1 of X, so you write W of X in transaction 1. Okay, in transaction 3 you write R of X because it is written R3 of X. Then we have W2 of X, so we have to write W of X. After writing, you please check it clearly. How many operations are there? 5 operations are there, and we have written all the 5 operations. If you have converted the sequence into a table properly, then only you can solve the question properly, otherwise you will do some mistake. So now we have converted the sequence into a table. See, directly I can solve from the sequence, but for beginners it will be difficult to understand. So I have converted into an equivalent table so that you can easily solve how to solve the precedence graph for this table. Okay, so let me draw the precedence graph. Now the precedence graph will tell me how many transactions are there and how the conflict operations will be represented. If in the precedence graph, if you find any cycle, then I can say that it is not a conflict serializable schedule. If there are no cycles, I can say that it is conflict serializable schedule. So as we are saying the precedence graph, any graph will have basically two things, a nodes and edges. What are the nodes are here? How many transactions are there? Those are the nodes in this one. So nodes represents the transaction. So we have 3 transactions are there in the given question. So we will write 3 nodes. You can write any sequence, transaction 1, transaction 2, transaction 3. And then in a graph we will have edges. Here the edges we will write. Here it is a directed graph, so we will have directed edges between. When we will have a directed edge between transaction 1 and transaction 2 is that if there is a conflict operation from transaction 1 to transaction 2, then I will draw an edge from transaction 1 to transaction 2. So with this one, let me explain how we will draw the edges. So we have a read of X. Then we have to see what are the conflict operations are possible for this read of X. Read of X, read of X. It is not a conflict operation. We have 3 conflict operations. Let me explain. We have read of X and W of X. Okay. W of X, write of X, and write of X is a conflict operation. Then write of X, read of X is another conflict operation, whereas read of X is not a conflict operation. Is it clear? And these should be, this data item should be same, and the read is performed by one transaction, write is performed by another transaction, then only we will say it is a conflict operation. Okay, so with this one I think you have understood what are the conflict operations. So we will construct the graph. So read of X is not a conflict operation. Okay, now read, then we have read this operation, means after this one we have this one, because we will not check with the operations which are there in the transaction 1 itself. So this is not a conflict operation. Now read of X, W of X, it is a conflict operation. What is the conflict operation is saying? R1 of X, W2 of X. So we will draw an edge from transaction 1 to transaction 2, because the conflict operation came from R1 of X to W2 of X. Meaning is that if you are finding any equivalent serial schedule for the non-serial schedule, first transaction 1 should come, then transaction 2 should happen. So that's why we should have a direct edge from transaction 1 to transaction 2. So this operation we have performed. So now we will see this one, read of X, then W of X. Is it clear? So read of X is there and write of X is there. So which is a conflict operation. What is this conflict operation is saying? Read of X in the transaction 2 is conflicting with the write of X in the transaction 1. So read of X in transaction 2 is conflicting with the write of X in the transaction 1. So what is the meaning? we should have an edge from transaction 2 to transaction 1. Okay, is it clear? So now itself I can say that the given is not a conflict serializable, the given option, because we have a cycle. But for your understanding, let me complete the entire precedence graph. Here itself you can stop and say that the given option is not conflict serializable, but for your understanding let me explain again. Okay, means I will finish the entire precedence graph. Okay, so read of x, this one is performed. Now this one is not a conflict because both are a read options. So we have finished the what are the conflict operations possible with this read of x. So next operation is write of x. This write of x is conflicting with read of x in the transaction 3. So what I can write is write of x, means write operation in transaction 1 is conflicting with the read of x in the transaction 3. So what I have to draw? I have to draw an edge from transaction 1 to transaction 3. So there will be a directed edge from transaction 1 to transaction 3. Then next one we will have this operation, means write of x and this write of x. So which is conflicting is write of x to write 2 of x, means write on data item x in transaction 1 is conflicting with write of x in transaction 2. So there will be an edge from transaction 1 to transaction 2. Already we have an edge from transaction 1 to transaction 2. So we no need to redraw the edge again. Okay. So we have identified what are the conflict operations which are possible with this operation. So we have finished. Now we will come to the next operation, read of x. Read of x and write of x is a conflict. So what is that one? R3 of x to W2 of x. So there should be an edge from transaction 3 to transaction 2. So after this one only this operation is there, so this is conflicting. Okay, now we have finished what are the conflict operations possible with this read of x. Then we will check what are the conflict operations are possible with this write of x in transaction 2. Now if you see that after this operation there are no other operations in the transaction 1 and in transaction 3, so we can stop the precedence graph construction for this non-serial schedule. Now if you see that there is a cycle here, transaction 1 to transaction 2 is going on and transaction 2 to transaction 1 the x is going. So I can say that there is a cycle. As I said earlier, after constructing the precedence graph, if there is a cycle in the precedence graph, then you can say that the given non-serial schedule is not conflict serializable. Meaning is that it is not conflict equivalent to any of its 8 serial schedules, because we have 3 transactions. So the number of serial schedule possible is 3 factorial, which is 8. So the given non-serial schedule is not conflict equivalent to any of its 8 serial schedule. So option A is not a right answer. So now we will see the option B, option C, then option D we will go for it. Okay. So let me solve the option B directly. Okay. So R2 of x is there. How many transactions are there? R2, R1, R3. So we have 3 transactions are there because 2 suffix is there. The meaning is transaction 2 is there. Suffix 1 is there. So meaning is the transaction 1 is there. And 3 is there. So transaction 3. So we have 3 transaction 1, transaction 2 and transaction 3. So in the graph we will have 3 nodes. Okay. So now we will find out what are the edges. Now if you see that the first operation is R2 of x. So R2 of x meaning is that in transaction 2 you have a read option. So which is conflicting with what? Which is not conflict with R1 of x, because read and read on a same data item will not have any conflict. Whereas R2 of W2 of x, lot of people will confuse, they will say that it is a conflict operation. It is not a conflict operation because both these operations belong to same transaction. we have to see the conflict operations with the other transactions. So both these operations belong to same transaction, so it is not a conflict operation. So R2 of x and R3 of x, even it is not a conflict operation because both are read operations. Now R2 of x and W1 of x, it is a conflict operation because this read operation is performed in transaction 2 and this write operation is performed on a transaction 1, and both are performing on the same data item x. So I can say that it is a conflict operation. So what is the directors I will draw? Transaction 1 to transaction 1, there will be an edge. So we have finished what are the conflict operations possible with this read option. So we have finished that one. So now we will identify what are the conflict operations are possible with read 1 of x, means read on x in transaction 1. Read of x and W2 of x, is it a conflict operation? Yes, it is a conflict operation. How I can say this read of x is belongs to transaction 1, write 2 of x is belongs to transaction 2, and both are performing on the same data item. So I can say that it is a read write conflict. So what is the edge I need to draw? Transaction 1 to transaction 2, there will be an edge. So we can say here itself that this is having a cycle, so it is not conflict serializable. For better understanding, I will finish the entire precedence graph. But here itself, when you are solving the gate, we cannot solve entire one because you will have to check about your timings, everything, because you have to finish the each question as early as possible to get good score in the gate. So here itself you can stop and you can say that this is not the right answer. But as I am teaching for beginners, so let me finish the entire one. So R1 of x, R3 of x is not a conflict. R1 of x and W1 of x is also not a conflict because lot of people will think that this is read and write conflict, but both belongs to same transaction, so it is not a conflict. So this is finished. Now W2 of x and R3 of x, so which is a conflict operation. So what is the conflict operation? Transaction 2 to transaction 3, it is a conflict. And W2 and W1 of x, which is also a conflict. So it is a write conflict. What it is saying? Transaction 2 to transaction 1. Already we have an edge from transaction 2 to transaction 1. So I can say I no need to draw the again the edge. So this is finished. Now R3 of x and W1 of x. Again it is a conflict. So it is saying that there will be an edge from transaction 3 to transaction 1. So this is the completion of the precedence graph for this non-serial schedule. You can ask me, sir, after this you have not finished R3 of x and W1 of x is done, then W1 of x, why you are not compared? Because there is no other operations in the options, so we cannot check what are the conflict operations. This will not create any conflict operations in the other operations which are not there. Okay, so we have finished the precedence graph construction for the option B. As there is a cycle, so I can say that the option B is also not a right one, it is not a conflict serializable. So we have checked option A and option B and both are not right. We will see the option C. Okay, so first we have to find how many transactions are there. There are three transactions are there because one suffix is there, two suffix and three suffix. So the meaning is that we have three transactions. Okay, so we will find what are the conflict operations. If you see that the first one is R3 of x and R2 of x, it is not a conflict operation because both are excuse me, R3 of x and R2 of x is not a conflict operation. R3 and R1 of x is not a conflict operation. R3 W2 of x is a conflict operation because in transaction 3 you have a read on data item x, and transaction 2 you have a write operation on data item x. So it is a read write conflict. So I have to draw an edge from transaction 3 to transaction 2. Is it clear? So the next one is R3 and W1 of X. Again it is a conflict. So you should draw an edge from transaction 3 to transaction 1. Okay. So we have identified what are the conflict operations with this read. Then we will check with this one. R2 of X, R1 of X is not a conflict because both are read operations. R2 double 2 both belongs to same transaction, so it is not a conflict operation. R2 and W1 of X is a conflict operation because read is performed on a transaction 2, write is performed on a transaction 1, and both operations are performed on a same data item X. So I can say that transaction 2 to transaction 1 there should be an edge. Okay, so we have identified what are the conflict operations with this read option. So we will see the R1 of X and W2 of X. It is a conflict operation. So the conflict operation is saying that transaction 1 to transaction 2 there will be an edge. If you see that there is a cycle here itself, we can stop and say that it is not conflict serializable, but I will finish the entire graph. R1 of X, W2 of X, we have finished. R1 of X, W1 of X is not a conflict operation because both belongs to same transaction, so it is not a conflict. So this is finished. Now W2 of X and W1 of X, it is a conflict operation. So the conflict operation says that there should be an edge from transaction 2 to transaction 1. Already we have an edge, we no need to draw again another edge. Okay, so this is about, we have finished about the construction of precedence graph for this operation, for this option, and we can say that there is a cycle, so I can say that this is also not a right answer. So if all three are means out of 4, if 3 are wrong, obviously this will be right, but in gate we cannot trust anything, we have to solve it and then we will check it. Sometimes they can give none of the above also. So for better understanding, let me solve this one. So how many transactions are there? 2, 2, 3, 1. So we have 3 transactions. Transaction 1, transaction 2, transaction 3. Okay. So R2 of X, W2 of X is not a conflict operation because both belongs to same transaction. R2 of X, R3 of X, both are read operations, so it is not a conflict. R3, R1 is not a conflict. R2, W1, it is a conflict operation because R2 which is performed on a transaction 2 and write is performed on transaction 1 and both are performed on a same data item X. So I can say that it is a conflict operation. So there will be an edge from transaction 2 to transaction 1. Okay, so we have finished the read of X. Now we will come to W2 of X and R3 of X. Is it a conflict? Yes, it is a conflict because it is a write operation and this is a read operation. Both performed on different transactions but on a same data item. So I can say that it is a conflict operation from transaction 2 to transaction 3. Okay, now W2 and R1 of X, it is a conflict operation. So we have to draw an edge from transaction 2 to transaction 1. Already there is an edge, so we no need to draw again. Now W21 of X and W1 of X, again it is also a conflict. So there should be an edge from transaction 2 to transaction 1. Already we have an edge, so we need to draw again. So up to here it is finished. Now R31 of X and R1 of X, both are read, it is not a conflict. Okay, R3 and W1 of X, it is a conflict. So there will be an edge from transaction 3 to transaction 1. Okay, so we will draw an edge from transaction 3 to transaction 1. So this is finished. Now R1 of X and W1 of X, both belongs to same transaction 1. So it is not a conflict operation. So we have finished the constructing of precedence graph for this option D. Now can you see that there is any cycles here? There are no cycles. If you see that there is an edge from here and edge from here, so I can say that there is no cycles. So I can say that it is not, it is a conflict serializable because there are no cycles I can say that it is conflict serializable. Then you can ask me, sir, if it is conflict serializable, it should be conflict equivalent to some serial schedule. What is that serial schedule is? We have to use the topological order, okay? Because if you see that there is an edge from transaction 2 to transaction 1, then transaction 2 to transaction 3, and there is an edge from transaction 3 to transaction 1. So the transaction 2 should start, then transaction 3 should start, and then transaction 1. How we got is, it is because of we have used the topological order to find the serial schedule, transaction 2, transaction 3, transaction 1. So this is the serial schedule which is conflict equivalent to option D, non-serial schedule. So it is a conflict serializable. So the right answer is option D. Thank you so much.